Hi class, I want to continue your lecture this week by talking about two advanced rules of probability. So in the previous lecture, what I talked about was just kind of like setting up some real basic probabilities and how you calculate them. So this section here, I'm going to talk about how you do some of the more advanced rules. Okay, so the first two rules we'll talk about is something called the addition rule, and then we'll talk about complements. Okay, so there are objectives for this lecture that I want to get through is I want to use the addition rule for disjoint events. I want to use the general addition rule, and then I want to compute the probability of an event using what we call the complement rule. Okay, so first thing is we're going to use the addition rule for what are categorized as disjoint event, disjoint. So what the heck are disjoint events? So two events are disjoint if they have no outcomes in common. Okay, so another name for disjoint events is that they are mutually exclusive, so they cannot happen at the same time. Okay, so disjoint events, two separate disjoint events, can't observe them happening at the same time. So to illustrate this, we often draw pictures of events using what are called Venn diagrams. Okay, so these pictures represent events as circles. So this circle, this purple circle E, purple circle here is called E. It represents event E, and this green circle represents event F. Okay, so the rectangle here on a Venn diagram represents the sample space, and each circle represents an event. So inside this blue rectangle, we see that all the possible outcomes that could happen are 0, 1, 2, and then over here we have 3, 4, 5, 6, 7, and then we have 8 and 9 over here. Okay, so for example, suppose we randomly select a chip from a bag where each chip in the bag is labeled the numbers 0 through 9, so there's 10 different outcomes. We let E represent the event, choose a number less than or equal to 2, and we let F represent the event, choose a number greater than or equal to 8. So you can see that events E and F are disjoint. They cannot happen at the same time, okay? Because I can't have a number that's both less than or equal to 2, while at the same time being greater than or equal to 8. So these events are disjoint. Can't happen at the same time. So if I say, hey, what's the probability of E? Well, there's 1, 2, 3 things in event E. So the number of elements in E is 3. Divided by the number of elements in the sample space is 10. So that's just 3 divided by 10, which is 0.30. Well, what's the probability of event F? Over here, there's a green circle. Well, there's 2 things in event F. 2 divided by 10 gets you 0.20. That's great. So the probability of E or F happening, okay, so think about E or F. That means either one could happen. Well, you look at the number of objects that are in E or in event F, so that's 0, 1, 2, 8, and 9, so there's 5 of them, divided by the 10 total outcomes, that's 0.50. Well, check this out. Well, look at this. If you were to just take the probability of event E and add it to the probability of event F, you would get the same thing. So it looks like when these two events are disjoint events, that you just add the two together, and that will give you the probability that either E or F happens. So that tells us that our general addition rule for disjoint events, if E and F are disjoint or mutually exclusive events, then the probability of E or F happening is just the probability of E plus the probability of F, and that's it. Now, what if the events are not disjoint? So then we have this thing called the general addition rule. So for any two events, E and F, if they are not disjoint, so I'm going to rephrase that. If they are disjoint, this last part is just equal to 0. But suppose they are not disjoint, so they can happen at the same time. So you take the probability of E or F, it would be equal to the probability of event E plus the probability of event F, but then you'd have to subtract away the probability of E and F happening. This subtracts away the double counting here if you were to just add them straight up like this. All right, let me give you an example. Suppose that a pair of dice are thrown. Okay, so we're going to let E be equal to the first die. The event E is equal to the first die is 2, and we're going to let F be the sum of the die is less than or equal to 5. Okay, so here's what we're actually talking about here is the game of craps. So these are all the outcomes for the game of craps that could happen. So you could roll a 1-1, a 1-2, 1-3, 1-4, 1-5, 1-6, all the way down to a 6-6. So it looks like if you were to add up all these outcomes, there would be 36 different outcomes. Okay, so we have two events here. we're going to let E be the first die as a 2. So the first die as a 2 would be this one, this one, this one, this one, this one, and this one. Okay. So can you also have the first die be a 2 and the sum of the die is less than or equal to 5? Absolutely. That would be this one, and this one. So these events can happen at the same time. Okay. So we're going to use the general addition rule to figure this out. So the first one is the probability that the first die is a 2. Well, there's 6 ways that could happen. So that's 6 out of 36, or 1 out of 6. The next event here was the number of, let me go back and show you. Event F was the sum of the die is less than or equal to 5. So if you were to count here, so this would be 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and so on. You would see that there's 10 dice whose sum is less than or equal to 5. So that simplifies to 10 over 36, which is 5 over 18. But how many ways can this happen? Okay, how many ways can both these two events happen at the same time? Well, the number of ways that a die can be, first die can both be 2, and the sum is less than or equal to 5, let me go back, would be this one, and this one. So it's 3 of them. Okay, so that simplifies to 3 out of 36, or 1 out of 12. So in this case, because these events can happen at the same time, the probability of E or F is equal to the probability of the first event, plus probability of the second event, minus the probability that these events will happen at the same time. So it's 6 out of 36 plus 10 out of 36 minus 3 out of 36, which just simplifies. 6 plus 10 is 16, minus 3 is 13 out of 36. All right, let's just do a quick ending this one on talking about probabilities using the complement rule. Okay, so we're going to let S denote the sample space of a probability experiment and let E denote any event. Then the complement, denoted E with a superscript C, is the outcomes in the sample space that are not in the outcomes of event E. So let me go back. So if this is event E, right here, the numbers 0, 1, and 2, the complement of E is everything outside of it. So it would be 3, 4, 5, 6, 7, 8, and 9. Everything outside of E is its complement. Okay? Well, we actually have a very simple rule. If E represents any event and EC represents the complement, then if I ask you to find the complement of E, it's just equal to 1 minus the probability that E will happen. So you can see this is the entire region. The area outside the circle represents E sub C, and this E right here represents just the event E. So here's a simple way to look at this. According to the American Veterinary Medical Association, 31.6% of American households own a dog. So what is the probability that a randomly selected household does not own a dog? Well, the probability that someone does not own a dog, well, the complement of not owning a dog is that you own a dog. So this would be 1 minus the probability that they own a dog. Well, look at this here. We know that as changing this percentage to a decimal. So this would be 1 minus 0.316, and it would be 0.684 when you do that subtraction. So that would be a very simple way you would use the complement rule. All right, class, I hope that video helped.